Okay, so this video is going to show you the 6 solutions to the 2017 AP Calculus AB free response questions. To start, we're going to start with question 1. Question 1 is a calculator question. Question 1 states, a tank has a height of 10 feet. The area of the horizontal cross-section of the tank at height h is given by the function a, where a of h is measured in square feet. The function a is continuous and decreases as h increases. Selected values for a of h are given in the table above. So before we even start, we're just going to try and approximate as to what the tank actually looks like. This obviously is approximation because we don't actually know what it looks like, but we can infer using the data that the function a decreases as h increases, and function a is the area of the cross sections. Cross sections kind of look like this, and we know that as the height increases, these cross sections are going to decrease, so therefore that's just going to get smaller as you go up. We also know that the height of the tank is 10 feet, and I also graphed these approximations on a graph. So question A asks, use a Left-Riemann sum with the 3 subintervals indicated by the data in the data table to approximate the volume of the tank. Indicate the units of measure. So Left-Riemann sum, basically what you do is you draw rectangles using the left y value and connecting it to the x value. And you're going to make 3 of those using the 3 subintervals, and it's going to look something along the lines of this. So you're going to have 3 rectangles again. The first one's going to be 2 by 50.3, the second one's going to be 3 by 14.4, and the third one's going to be 5 by 6.5. And after you know this information, you basically just find the area of all 3 rectangles using base times height. So it's 2 times 50.3, 3 times 14.4, and 5 times 6.5 to get 176.3 feet cubed, which is the approximation for the area of the tank. Question B asked, does the approximation in part A overestimate or underestimate the volume of the tank? And explain your reasoning. So we know that A of h decreases as h increases. So I first and foremost drew a graph at which the function decreases as x increases. And as you can see, I drew the Left-Riemann sums, and there's a lot of this orange, which is extra area. And since there is this extra area, we can say that this is an overestimate, because if this was a decreasing graph, there would be all this extra stuff, which we wouldn't want. So based on this information, that function a is decreasing as h increases, we can state that is overestimate. Question C asks, the area in square feet of the horizontal cross-section at height h is modeled by the function f, given by f of h is 50.3 over e to the 0.2h plus h. And based on this model, find the volume of the tank, including units of measure. So, as I previously stated, if you add all of these areas up, if you found the cross section and were able to add all the cross sections up as the change in height becomes really, really, really small, and you add them all up, you'll be able to find what the volume of the tank is. So basically, in order to do that, you're going to need to use an integral. So what I did, using the knowledge that f of h is the area of the tank, or the cross sections of the tank, and f of h is 50.3 over e to the 0.2h plus h, I'm going to use the integral from 0 to 10, so it's 10 feet, of f of h. And when I put this in my calculator, I get 101.325 feet cubed, which is the exact measurement of volume for the tank itself, which actually makes my answer in B correct, because my answer in A was greater than that of the actual volume. So now we're going to go into D. D, in my opinion, is the hardest question. D states, water is pumped into the tank. When the height of the water is 5 feet, the height is increasing at the rate of 0.26 foot per minute. Using the model from Part C, find the rate at which the volume is changing with respect to time when the height of the water is 5 feet. Indicate units of measure. So before we even start, we're going to go into what we already know. We already know that the area is modeled by f of h, which is 50.3 over e to the 0.2h plus h, and h is height. We know the volume is the integral of the area from 0 to h. I use v of h as my volume function. And based on question D, we know that when h equals 5, the rate at which the height is increasing is 0.26 foot per minute, which can be wrote as the change in height over the change in time, which is dh dt, is equal to 0.26. What we're looking for is the change in volume in respect to time, which can be modeled as dv over dt when h equals 5. So I had a lot of trouble finding out how to actually find out how to calculate dv over dt, but then I realized I could break it up into two things. dv over dh, which is the change in volume in respect to the change in height, times the change in height over the change in time when h equals 5. And using the prior knowledge that we already know, we can find out what these things are. So the derivative of the volume function, which is this, is simply just the derivative of this integral. And when you're finding the derivative of integral, it's just the function inside. So this can be written as f of h. And dh over dt when h is 5, we already found that's 0.26h. So, in other words, dv over dt when h equals 5 is just f of 5 times 0.26. When you put that into a calculator, finding f of 5 by plugging in 50.3 over e to the 0.2 times 5 plus 5, you get 1.69 and some change. And you also get feet cubed per minute. And always remember to use units. You get feet cubed per minute because f of h is feet squared, and dh dt is represented by foot per minute, so that's feet cubed per minute. And that's the end of question 1.